H2O plus H2O gives me H3O plus OH minus, okay? These are the two ions that water, when it reacts with stuff, splits up into. What are a couple of things that I know about these ions? I know that when I multiply the two together, the concentrations of the two, what will it give me? Okay, it gives me 1 times 10 to the negative 14. We'll always do that, right? In the solution, that will happen. So, another thing that I know is that they're equal to each other, right? At 1 times 10 to the negative 14, this autoionization is 1 times 10 to the negative 7 times 1 times 10 to the negative 7. They're equal to each other. So that's something else to keep in mind. Okay? So, remember the Chatelier's principle that we talked about? So if I was to add some sort of acid to this solution is what? It's just water. But in it, you'll find some of this. So if I added acid and I up this concentration, what does the Chatelier's principle say happens to the water molecules? Where would it go to hit equilibrium? If I up this side, it'll go this way. So what's happening is when I add a little bit of acid to water, small amounts, what happens is actually the autoionization of water changes because of its equilibrium point, and it rushes back. So what that means is when I add a little bit of acid, the concentration of hydronium that comes strictly from water goes up or down. It actually goes down. It's not as much, right? Because we're looking at water, specifically water on its own. The amount of this that water is producing lessens, right? Because of the Chatelier's principle. The reason why this is goofy is, let's say that I added this much. Let's say I added 1 times 10 to the negative 7 HCl to water. Somebody take the negative log of that and tell me the pH. Some of you probably don't have to. You recognize what it is. It's 7. Does that make sense? The pH is 7 of this. I add a little bit of acid and I'm neutral. Right? That doesn't really make sense. That should be lower than 7, right? That's the whole glitch. Okay? So this is because of the autoionization of water. You have to, at certain molarities of our strong acid that we're adding in a solution, at really small amounts, I have to start factoring in my autoionization of water. Because if I just take the negative log of how much acid I added, I'm going to get 7, something that doesn't make sense. It should be a little bit acidic. Not really acidic, but it should be like, what, 6.9, 6.7, something like that, lower than 7. So this is what is happening. Let's kind of look at how this works. Remember, when I added this much, water shifted back. So really, how much H plus as a group do I have in my solution? I have X, which is however much water is donating, right? We don't know that value. We just know that it was 1 times 10 to the negative 7. When I added a little bit of acid, it actually got smaller than that. So I should expect a number smaller than 1 times 10 to the negative 7. So I have X plus however much I added, because this is a strong acid, so if I added this much of it, I'll get this much of just H. So plus 1 times 10 to the negative 7. That, I'm putting this in the spot of my H plus concentration in the solution, multiplied by my hydroxide. And what did I say earlier? That they equal each other always, right? So that's also just X is equal still to what? 1 times 10 to the negative 14. So this is how you solve for a problem like this. Then what we need to do is just solve for X. And you're going to have to use the quadratic equation to solve for X. When I do that with this specific problem, adding this amount, actually, I can't remember. Dr. Macedoni did one as well. You'd have to use the quadratic, and I think the one that I solved for actually didn't use this. I think it used to the negative 8. So let me just switch that so I can get the right answers for you when you write this down. When you solve for X using this amount, right, you would get X equals 9.5 times 10 to the negative 8. That's what X equals. That's how much H plus water on its own is donating to this whole system. Water is making this much. So overall, my H plus concentration is this, that comes from water, plus my 1 times 10 to the negative 8. Somebody do the pH of that. Do this plus this, and then do the negative log of those. Anybody? I know he's doing it. 6 point what? 6.9. 6.98. Does that make sense? That makes, it's still really close to 7, but it should be a little lower than 7. This is a very small amount. So this makes sense. If you were to just take the negative log of 1 times 10 to the negative 8, you would have gotten 8, a basic pH when you added acid. It doesn't make sense. So please get this system down if you have an auto-ionization problem. Let me tell you where the cutoff seems to be. At any acid amount that you go to add, that is 1 times 10 to the negative 7 or smaller, that seems to be the areas of most, it's critical, like absolutely critical that you do this. Because if you take the negative log of 1 times 10 to the negative 7 or anything smaller than that, you get basic pHs, which doesn't make sense if we're adding an acid, right? That's when we must factor this in. So a quick summary. This times this equals that, right? And when the Chatlayer's principle tells me that, the H plus concentration that comes from the auto-ionization of water will go down as I add acid because of the equilibrium shift. So I should expect X to be smaller than 1 times 10 to the negative 7, and it was when we did it out. Plus what I added of my acid, in this case, sorry, we changed this to 8 just because I had done the problem with 8, times X, which was OH minus, they're equal to each other, is still equal to 1 times 10 to the negative 14. This system, you always be able to do it like this, okay? So we went over a little bit of time, but I feel like that was a really valid thing to do. And so, does anybody have any questions about that?
So why did you change it to -8 instead of -7?
The only reason I changed it, let me clear this up. The only reason I changed it is because the number that I solved for using the quadratic equation, I did 8. So I just wanted to give you a number that corresponded with the right values, right? 7, you would just have to do the quadratic on your own. It wouldn't be this, it'd be a little different. But when I did it, I used 8. I just forgot that I used 8. I didn't want to give you a false number here. That's why.
That's just like given in the problem, what's asked.
The problem would ask, what's the pH when I added, 1 times 10 to the negative 8 molar HCl? It should be a little bit acidic, right? Okay. So, okay, any other questions? Yeah, Andrew.
So when we get the X, why don't we do the add the 1 times 10 to the negative?
Perfect question. Let me drive this home again. When I solve for X here, I'm only solving for the amount of H plus that water, the auto-ionization of water, is contributing to the acidity of my solution, not my acid. So that solved for water will produce on its own 9.5 to 10 to the negative 8 molar hydronium ion. I got to add that to how much my acid gave me as well. And that's the total amount. Does that make sense? Yeah?
Is it more bases if you have a base with molarity of 10 to the negative 6 or higher?
Try it. I haven't had to do a problem with bases, but yeah, it would. Yep, it would. Anything else? Yeah?
Can you tell how to do the diprotic acids?
So, a diprotic acid is a good question. Corbin can talk about that real quick. And we'll actually stop this, and we'll answer your individual questions and everything like that, okay?
Okay, diprotic acids. Some of you guys had